Hi, good morning. This is Miss Webb. We're going to have a little music in the background because my daughter's practicing her scales. Um, Today we want to talk about the difference between observational studies, surveys, and experiments. It's kind of an introduction into uh, statistics. We're only going to do one lesson because it's the end of the year. Um, I'm a little bit upset because this is a really fun lesson to go over in class because it brings about a lot of discussion and we usually have a really good time with it. So since I don't have any class here, it's going to be a little dry and we're going to go over some vocabulary and I'll do my best to make it a little more interesting. We're going to talk about why random selection is important, and we need to recognize when it's reasonable to generalize and when it's reasonable to reach a cause and effect conclusion. Okay, let me get my pen. Let me go over here first. Okay, so again, in the beginning, we're going to talk about some definitions. So an observational study, it records the values of variables for members of a sample. There are several types of observational studies. The one that you're probably most familiar with is a survey or a poll. They are designed to observe subjects without any manipulation by the researcher. That's why they call it you're just observing. Okay, I'm going to get my highlighter going here. Okay, now a survey is a type of observational study that gathers the data by asking people a number of questions. Then we have an experiment. Let me go with yellow. I don't like the purple. An experiment, it assigns subjects to treatments to see what effect the treatment has on some response. So that's the big difference between an observational study and an experiment. Okay, and let's go. Okay, and this is in your notes. I just want to make sure you understand the idea because you're going to do a lot of this in your science classes. When you want to do a statistical study, you begin by asking a question that can be answered with data. That's kind of important. Okay. And the second, because you have to be able to collect it. Second step is collect the appropriate data, organize and analyze the data. The third step is to possibly arrive at a conclusion in the context of the original question. Now, this sounds pretty easy, and what you find out in statistics is, well, this is what makes it usually this lesson really interesting. There are so many ways to screw it up. There's so many ways to think you're doing a random sampling and you're not. You're not asking a very good question. It's confusing. People try to come up with conclusions, and it's not really based on an experiment. It gets pretty interesting. I almost think it's more fun to look at all the mistakes and statistics than it is to go straight with it. But when you're doing any of your humanities, you're going to go over to psychology, a lot of your business, marketing. It's really important to be good at this and to know how to do a statistical study and make sure that you're doing it correctly, or you're going to spout out a bunch of stuff that isn't true. So let's go to, okay, the objective of an observational study and a survey. You're trying to learn the characteristics of some population. They do this a lot in business marketing. Okay, the data needs to be collected in a way that result, okay, and here's the important part, representative sample. Okay, and there, like I said, there are a lot of examples when somebody thinks they're doing a representative sample and it's not. Okay, and the random selection is absolutely necessary. So this is really important. And some of these you think, oh yeah, no problem. You got to really think about it. Okay, the object of an experiment is to answer questions as what is the effect of treatments on a response variable. Okay, and you need to make sure that it doesn't favor one treatment over another. That would be important. And also your random assignment of subjects is very important as well in an experiment. Okay, now an observational study is one in which the values of one or more variables are observed, okay, with no attempt to affect the outcomes. You're not trying to affect the outcomes, you're just observing. A survey is a kind or a type of observational study. It requires asking a group of people to respond to one or more questions. A poll is an example of a survey. You're just asking them some questions. Okay, now an experiment differs. Here's the big deal. How do they differ? And this is part of the assignment you're going to get, is how do they differ? Because subjects are assigned to treatments for the purpose of seeing what effect the treatment has on the subjects. For example, an observational study. In a random sample of students, it was observed that those students who played a musical instrument had better grades than those who did not play a musical instrument. It's just you're making an observation, okay? And hopefully you did it with a random sample of students. When I was at UNM, I was broke all the time. The psychology department would actually pay you to be in different experiments. And mine, because I played an individual sport, they were doing an observational study of people that were in team sports, individual sports, and to see what kind of grades they got and what their GPA was. So that would be just an observational study. And in case you want to know, people that are in individual sports have higher GPAs than the ones that were in team sports. But that's just Miss Webb. Okay, an experiment, however, same type of thing, would be you're going to take a group of students who do not currently play a musical instrument, and they'd each be assigned at random to have to play a musical instrument for a certain period of time. And then at the end, we might compare their academic performance. Do you see the difference between these two? One, I'm just observing. The other one, I'm going to give you some treatment. I'm going to make you try an instrument and observe what happens. Okay, let me go to the next slide. Okay, so a survey, you're going to ask people to respond to one or more questions. And this one, I believe it's in your student notes. It talks about how when you do a survey, it's really important about how you ask the questions. And constructing clear questions may not be as easy as you think. For example, do you like your school's cafeteria food? Well, what if you bring your own lunch? What if you like salad but do not like the turkey sandwich? Okay, or you might want to do something like this, which is for each of the following items offered by our cafeteria, check the appropriate box. Oh, well, I like this item, I do not like this item, or I have never tried the item. Because, I bring my own lunch. So you want to be really careful in how you do the questions and how you ask them. It's easy to determine if a study is a survey. A survey asks people to respond to questions. But surveys can be flawed in several ways. Questions can be confusing. Consider the following question. What kind of computer do you own? Circle 1, Mac or IBM? Well, what if you don't have a Mac or an IBM? What if you have an Apple? What if you don't even own a computer? So a lot of times a better question might be, well, first, do you own a computer, yes or no? And then what brand of computer? Or you could give them a long list and then have an others, make them be able to do an X with other. Okay, now do you like the school's cafeteria food? That was the one I did from before. And it'd be probably a lot better if you gave them a list to pick from. Okay, something else to consider with surveys is how survey participants are chosen. If the purpose of the survey is to learn about some population, they need to be randomly selected from the population of interest. If people are not randomly selected, misleading conclusions from the survey data may be drawn. Okay, the most famous example of this was back in 1936, and no, I was not alive at that time. Okay, when the Literary Digest magazine predicted that Landon, anybody heard of Alf Landon? I haven't. They said he was going to beat the president, Franklin Delano Roosevelt. Heard of him? Yeah. They said it was going to be pretty much, 2-1. However, it wasn't even close. Roosevelt absolutely killed the guy. And what happened was the Literary Digest, the way they didn't come up with a random population. They looked at people that were a lot more wealthy, people that had a subscription to a magazine at that time, when a lot of people were absolutely broke and didn't have magazines. They looked at people that were in club memberships. They surveyed a bunch of people that were, pretty wealthy compared to the rest of the population. But most of the population was in dire straits, and they voted for Roosevelt. Okay, here's another one. I'm just going to kind of go through some of these. The primary difference, and this is really important, between an observational study and an experiment is it imposes treatments on subjects. An observational study does not impose treatments on the subjects. There's no attempt to influence their response. Sometimes situations are encountered in which an observational study needs to be done because an experiment cannot be performed. It would be unethical, to say the least, to impose a dangerous treatment on people, such as assigning them to smoke a pack of cigarettes per day or exposing them purposely to asbestos. You can't do that experiment. It would be unethical. Here's some examples they give you. You want to think about, let's see, which one's this one? Oh, researchers investigate the link between the use of cell phones and brain cancer. Okay, there are two variables of study. One is the extent of the cell phone usage, and the second is whether or not the person has brain cancer. Okay, both variables were measured for a group of people. This is an observational study. There was no attempt to influence people's cell phone usage to see if different levels of usage made any difference in whether or not the person developed brain cancer. Okay, why would studying any relationship between asbestos exposure and lung cancer be an observational study and not an experiment? Because this would be unethical to expose people to asbestos. Okay, random sampling of subjects is important in observational studies, also to eliminate bias. On this one, let me see what this one was. A lot of times they want to be able to determine, it says, if potato chips made in a factory contain the desired amount of salt. Okay, well, a sample of chips would be selected randomly so the sample can be considered to be representative of the population of chips. And they want us to talk about, well, how would you do a random sample of 100 chips from a conveyor belt of chips? What if you picked one out of every 3? What if you have a random number generator and that's the number, number 7, go pick that one. This is really, really important because remember, I worked for Intel, and in manufacturing, we're making all of these chips, semiconductor chips, and I cannot test every single one of them, or I can't make it to production. I'm not going to make any money if I go and just test every single one of them. So what we do is we come up with a process. We don't make any changes to that process. And then we randomly select a certain number of the chips to test them. Because I can't test 100, but I can test like 3 out of the 100 and see if they are working correctly or performing correctly. If they are, then we're great, we keep going. However, if some of those come out and there's a problem, then we stop our production line. And then we do additional testing and additional sampling to see, okay, do we have a problem? Did we do something wrong? And now we're producing a bunch of chips, semiconductor chips that aren't going to work. So we at Intel would brag about how good we were at this, that we were very careful, that we tested better than everybody else, that we had a good sampling, That's why our chips were more reliable than other people. We also had very specific, you could not make changes to our production process unless you went and did it in another, an experimental way before you ever put it into the production line. So you actually do this quite a bit. If you're in business, this would be very important. Okay, now this is the other one that gets everybody, is the cause and effect. Okay. So, and some of these are kind of humorous. That's why I'm kind of bummed that you guys aren't here with me. There's a strong positive relationship between the number of television sets in a country and the life expectancy of its residents. So, well, could one conclude that increased life expectancy of the country, they just need to increase the number of television sets? Surely not. But why not? Well, a rich country would have lots of television sets. But they would also, if you were a richer country, would have more access to health care and to fresh water, which provides a better quality of life, okay, and hence a higher life expectancy. So you have to be very careful when you do any cause and effect, statements. They have something called the lurking variable that you have to be really careful about, and that's like on this one would be your economic status is your lurking variable. So a lurking variable is one that causes two variables to have a high relationship even though there's no real direct relationship between the two variables. Here's another one. Did you know that ice cream sales and the number of drowning accidents are positively related? So can you conclude that ice cream sales cause drowning accidents? No. The lurking variable here is the time of the year. Think about it. You have a lot more ice cream sales in the summer, and you have more people going out and swimming, so you have more possibilities for drowning. So you have quite a few different things that you can look at where you have a lurking variable. The other thing that's really important, people are very interested in knowing what causes something to happen. The main disadvantage of an observational study, and man, if this is the one thing I want you to get out of this, is that the disadvantage of an observational study is that cause and effect conclusions cannot be drawn from any relationships observed in such a study. Period. Whether you like it or not, you cannot go and talk about cause and effect. Now, what might be nice is when you could do an observational study and that might go, oh, I think there might be a cause and effect. Let's do an experiment. Okay? But you just cannot do that. Just like the cell phone one, okay? The study indicates extensive use of cell phone is linked with brain cancer. It does not, you cannot give that cause and effect, okay? You could talk about people that have heavy cell phone users. They might have very stressful jobs, okay? And that might contribute to their poor health. But, and here's the biggie, an experiment must be done in order to establish causality. Can't do it. Cannot do it with an observational study. You can only do it with an experiment if you want to consider cause and effect. Okay, here's another one they talk about. This one, it has an observational study indicate that a certain type of tree did not have as much termite damage as other trees. Okay, so they wondered if there was some type of resin. Let me go back to yellow. From the tree that was toxic to the termites. Do you see how they did the observational study? And it says, well, maybe there is something. But then you have to do an experiment if you really want to know cause and effect. So what they did was they exposed some termites to the resin and others to plain water. So here's the experiment. Some were resin, some were plain water, and recorded whether the termites survived. Okay. The explanatory variable, the treatment variable, is the exposure to resin or plain water. And the response variable is whether or not the termites survived. So you have something called the explanatory variable, exposure type, reasonable variable, and whether they survived or not. Okay, so on this one, in the following observational study, so that's how you could maybe take an observational study and then go, oh, that might, let's go run an experiment to see if I can do a cause and effect. Okay, is the following an observational study or an experiment? Let's see, we have a whole bunch of questions of these coming up. Okay, and if you talk about is the experiment, if it's an experiment, can you identify the treatment variable and the response? Treatment variable and the response variable. Okay, and if it's an observational study, can you identify the population of interest? Okay, so here we go. A study was done to answer the question, what is the effect of different durations of light and dark on the growth of radish seedlings? 3 similar growth chambers, plastic bags, were created in which 30 seeds randomly chosen, that's nice, from a package were placed in each chamber. One chamber was randomly selected and placed in 24 hours of light, another for 12 hours of light and 12 hours of darkness, and a third for 24. So after 3 days, the researchers measured and recorded the lengths of the radish seedlings for the germinating seeds. So on this one, can you see it's an experiment, okay? And if you talk about the treatment variable, that's the number of hours exposed to light, and the response variable is the lengths of the radish seedlings. Okay, so a lot of times still want to know that. I'm going to walk through these examples with you and talk to you about some of the things that, you know, whether they're observational or if they're an experiment, and maybe some things that you might want to talk about. So this one is whether boys or girls at learning are quicker at learning video games than girls. So 20 randomly selected boys and girls, randomly selected girls played a video game as they had never played before. The time it took them to reach a certain level of expertise was recorded. This is an observational study. The children were observed and no treatment was administered to them. Okay, so the population of interest was all boys and girls who play the video game that had never played before. So the study was to see who was quicker at achieving certain levels of expertise, but it's not an experiment, it's an observational study. Okay, at your statistics project, you collect data by posing 5 questions on poster board around your classroom and recording how your classmates respond to them. Okay, so this is probably a survey because you have questions were asked of classmates, and students may question whether this is really, you know, is this really a sample survey, since everyone, the whole class went around your classroom and recorded how your classmates responded to them. So it's not necessarily, you didn't get a sample survey, and they were not randomly chosen. It's everyone in the class. So that's something that you might, there's another thing that they call this, full marks to those who suggest that this is what you call a census. And we haven't talked about that. That's something that we would get into if we got to go more in statistics. Okay, here's another one. Professional sports team traded its best player. The local television station wanted to find out what the fans thought of the trade. You see these all the time on news programs. They ask viewers to call one number if they favor the trade and a different number to oppose the trade. At the end of the news program, they announced that 53.7% of the callers favored the trade. Now, this is a survey, but it's called a voluntary response. And it's a very poor way of gathering data since subjects are clearly not randomly chosen. They're not randomly chosen. It's everybody watching and who wants to take the time and effort to call it in. So it doesn't usually give you a very objective observation here. Okay, the local Department of Transportation is responsible for maintaining lane and edge lines on its paved roads. There are 2 new paint products on the market. 20 comparable stretches of road are identified. Paint A is randomly assigned, I like that, to 10 of the stretches of the road, and paint B to the other 10. The department finds that paint B lasts longer. Okay, so for this one, it is an experiment, even though you're not looking at necessarily people, okay? Oh, wait, no, I messed this up. I'm looking at the other one. This one is an observational, let me see, look. I'm looking at the wrong one. This is an experiment. The subjects of the road, the stretches of the road are the subjects, okay? And the response is the longevity of the paint. They have a whole bunch of other national traffic ones, so it's getting mixed up. However, you do have a possible lurking variable here. You could have things like weather, traffic, that could affect this experiment. Okay, so that's where one you might want to note the lurking variable, possible lurking variables. Okay, here's the other one I was thinking about. Okay, the National Highway Traffic Safety Administration conducts annual studies on drivers' seatbelt use at random selections of roadway sites in each state to determine if seatbelt usage is increased, and data is now analyzed over 2 successive years. This is definitely an observational study because no treatment is administered. You're not trying to affect the outcome at all. They have it says if you look making sense of statistical studies, they have a big thing that you can see this actual study. Okay, people should brush their teeth at least twice a day for at least 2 to 3 minutes each brush. For a statistical class project, so you're asking a question, a random number of students at your school questions concerning their toothbrushing activities. So this is a survey. Okay, let's look at this last one. A study determines whether taking aspirin regularly helps to prevent heart attacks. A large group of male physicians of comparable health, here we go, were randomly assigned equally to taking an aspirin every second day or to taking a placebo. After several years, the proportion of study participants who had suffered heart attacks in each group was compared. This is definitely an experiment. The male physicians were randomly assigned to one of the 2 treatments. The treatment variable is the aspirin or no aspirin. The response variable is whether or not they suffered a heart attack. So do these help in identifying the difference between observational studies, surveys, which are a type of observational study, and experiments? Okay, and remember, cause and effect can only be used for experiments. Okay, let's look at some of these. Okay, for the following, is the stated conclusion reasonable? Why or why not? A study found a positive relationship between the happiness of elderly people and the number of pets they have. Therefore, having more pets causes elderly people to be happy. What do you think here? Okay, now is this an observational? This sounds like this is an observational study. So you cannot do this. You cannot have that causational, you can't say it's a cause and effect. To do an experiment, you might have to get 40 elderly people randomly, give them an assessment on how happy, their happiness scale, and then have the ones that you have assigned, some of them to no pets, some of them to 1 pet, some of them to 2 pets, and after a certain amount of time, then you could measure their happiness scale, and then that would allow you to say this. But you'd have to do an experiment, not just an observation. If you want to make this big, here it is, this big statement here. Therefore, this is the cause and effect. Now, what's interesting on statistics, you see this all the time on television and with commercials. If we were doing this in class, I would definitely have some pretty fun things that we could do to see if you could come up with something with a lurking variable or with something that was only an observational study, but present it in a way that, oh, definitely you would think the cause and effect. People do this a lot. So you have to be really careful. Okay, let's look at number 3. A researcher wanted to find out whether higher levels of a certain drug given to experimental rats would decrease the time it took them to complete a given maze to find food. Okay, why would the researcher have to carry out an experiment rather than an observational study? Okay, because they want to see the cause and effect. Okay, and to have a cause and effect, you have to do an experiment. Okay, so if you were going to describe an experiment that the researchers might carry out based on 30 comparable rats and 3 dosage levels. Well, first you'd have to randomly assign the rats to 3 different groups and give one group 0 milligrams and time them on their time through the maze. Another group 1 milligram, time them through the maze, and 2 milligrams. That would be reasonable, and that is an experiment. Okay, so there are 3 major types of statistical studies. You have the observational study, a survey, which is really a type of observational study, and experiments. An observational study records the values of variables for members of a sample. A survey is you're going to gather data by asking people. So you're not just going to go and record the data. You're going to ask people to get particular questions to get your data. An experiment assigns subjects to treatments for the purpose of seeing what effect the treatments have on some response. To avoid bias in observational studies and surveys, you have to select your subjects randomly. Cause and effect conclusions cannot be made in observational studies, and in experiments, it's important to assign subjects to treatments randomly in order to make cause and effect conclusions. I hope you had a good year. I thought this was a nice introduction to statistics. We went pretty in depth with probability, and this is your last lesson and last assignment. Thanks.